Welcome to Reasoning and Proof. Today we're going to check out different ways to prove something is true. For example, if your friend says that the sky is blue, how do you know that's true? How do you show that's true? If your friend says the grass is blue, how do you disprove that? How do you show that's false? We're going to find out today. The first type of reasoning we're going to learn is inductive reasoning. Now you probably already know what it is because you've used it so many times. You just didn't realize. So let's check it out. Inductive reasoning goes like this. Let's say our friend Amy goes to a new school. The first 3 students she meets in homeroom class are unfriendly. But because of this, she concludes everyone in her homeroom class is unfriendly. Wow, that's a big jump. But that's what Amy decides, right? Maybe because she's having a bad day, she thinks that everyone in her homeroom class is just plain old mean. Okay, so let's go through her argument again. She goes to a new school. The first 3 people she meets are unfriendly, so she concludes everyone in her homeroom class is unfriendly. So, what type of reasoning is this? This is inductive reasoning. When you start with a few specific cases. So, Amy sees that 3 kids are unfriendly to her. Those 3 kids are cases in math, okay? Those are specific cases of people being unfriendly. And based on just those 3 people, she reaches a conclusion. And she concludes everyone in her homeroom class is unfriendly. That's what we call in math a conjecture. In math, you call a conclusion a conjecture. Okay? And in this case, Amy's conjecture is a broad generalization. So inductive reasoning is when you start with a few specific cases and conclude to a broad generalization. Unfortunately, in geometry, inductive reasoning is not a valid method of proof, but it can give you some ideas, so keep it in the back of your mind. Next up in our list is deductive reasoning. What is deductive reasoning? Well, let's check it out. Deductive reasoning goes like this. Every triangle has 3 sides, right? And that's an accepted fact. Everyone agrees on that. Now, Carlos draws a triangle. Okay. Therefore, the figure Carlos drew has 3 sides. So do you see the logical reasoning there, right? You start with the accepted fact that every triangle has 3 sides. You draw a triangle, and now you say the triangle that you drew has 3 sides. Oh, this thing's not gaining charge. Okay. So this is deductive reasoning. That's exactly what deductive reasoning is. And guess what? It's a valid method of proof. That means you're going to use it a lot in geometry. Okay, so that being said, let's move on to why deductive reasoning works. Well, it works because you start with a bunch of accepted facts, right? You start with accepted facts and then you move on to a logical conclusion. That's what deductive reasoning is, and we'll use it a lot in geometry. Next up on our list of reasoning tactics, proving tactics, that's indirect reasoning, okay? Let's say you've got a crime. Someone robbed a bank. You got 3 suspects lined up, X, Y, and Z, and you want to know who committed the crime. Well, here's what you do. You check out their location. You see that person X was in a different place. You see person Z was in a different place when the crime was happening. So, by method of elimination, you realize that the culprit, the guy who committed the crime, is person Y. Send that guy to jail. So that's indirect reasoning. One way you can do indirect reasoning is method of elimination, right? Here's another way to do indirect reasoning. Let's say you want to prove something is true. Well, pretend that it's not true. That's going to give you a contradiction. And so, therefore, what you wanted to prove had to be true. Now, a lot of kids get mixed up with this, but we're going to see a bunch of examples, and hopefully that'll clear that up for you. And so, indirect reasoning is a valid method of proof. Next thing up we have is circular reasoning. Now, this one is kind of wacky, right? This one is kind of wacky. Circular reasoning goes like this. X is true because Y is true, and Y is true because X is true, and X is true because Y is true, and Y is true because X is true. I mean, it never ends, right? This is plain out wrong. Circular reasoning is not a valid method of proof. For example, it can go something like this. Everyone likes May because May is popular. Why is she popular? Because everyone likes her. Why does everyone like her? Because she's popular. So this is a circular reasoning. This is a circular argument. It is not a valid method of proof. Okay? And finally, we talked about 4 types of reasoning, but there's one more guy we got, and that's this one. Proof by counterexample. Let's say you want to prove someone wrong, right? All of us want to do that, hopefully. And how do you do that, though? Well, let's say someone told you all prime numbers are odd. Let's say someone came up on the street and told you all primes are odd. You want to prove them wrong. So how do you disprove that? Well, you show them the number 2. It's prime, but it's not odd, it's even. So you just disprove that guy using a counterexample. That's it, that's proof by counterexample. So, we talked about 5 methods of proof. We talked about inductive reasoning, not a valid method. Deductive reasoning, check. Indirect reasoning, check. Circular reasoning, nah, doesn't work. And proof by counterexample, check, which does work. And finally, the last thing we're going to talk about today are different properties of congruence and equality. Okay, so this is pretty cool. When you prove something, when you're actually proving something, doing the math, doing the bajingo, doing the statements, these are the things you'll need. So let's review them one by one. First up is the reflexive property. The reflexive property says that if, okay, it will sound so obvious you'll be kind of confused. Reflexive property says something is equal to itself. So 1 is equal to itself. 2 is equal to itself. A circle is equal to itself. I mean, you're probably thinking, why does this property exist? But it exists so that you're tortured. Anyway, just kidding. This is just so that mathematicians can rigorously and, prove something in a very, very focused, defined, rigorous way. So that's what the reflexive property says. It says something is equal to something, blank is equal to blank, U are equal to U, AB, line segment AB is equal to line segment AB, measure of angle 1 is equal to measure of angle 1. You get the gist. Apple equals apple, orange equals orange. It might sound obvious, but that's what we're going to use. What's next? Symmetric property. Symmetric property is, again, it might sound obvious, but we use it for proofs. Rigorous, defined proofs. So, for example, if angle 1 equals angle 2, if angle 1 is congruent to angle 2, then angle 2 is congruent to angle 1. It's just like saying if AB is equal to CD, then CD equals AB. You're just flipping it around, but it stays true. Okay, that doesn't change whether it's true or not. So that's the symmetric property. If A is equal to B, then B is equal to A. If C equals D, then D equals C. Okay, that's the symmetric property. Next up is the transitive property. That says that if angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3, then angle 1 is congruent to angle 3. So, it kind of goes like this. Okay, so, for example, if angle 1, this is what I'm telling you. Angle 1 is congruent to angle 2. And angle 2 is congruent to angle 3. That means angle 1 has to be congruent to angle 3. That's all the symmetric property, or the transitive property says. Wow, even I get mixed up. That's either embarrassing or a testament to just how hard this is. And finally, the last kind of property we got is, wow, this got all messed up. The last kind of property we have is the substitution property. That says something like this, right? If you have the measure of angle 1, here's an example, measure of angle 1 plus measure of angle 2 equals 90 degrees, right? And angle 2 is congruent to angle 3. So then you can just replace measure of angle 2 by measure of angle 3. So you'll get measure of angle 1 plus measure of angle 3 is 90 degrees. Alright folks, that's it for today. That's all you need to know for proofs. That's how you prove something. And in future lessons, we're going to actually prove a lot of statements. So in the future, whenever we need to kind of prove something in geometry, like the diagonals of a square are perpendicular, we're going to use these types of reasoning. So thanks for watching this episode of Flip Classroom. We'll check you out next time.